All right, hopefully that's coming up as being connected. I'll just give it a few more seconds to hopefully come up. Hopefully you guys can see me. Hi, everyone. Just to start off with, I'm going to get started very, very shortly with the actual lecture. I've got a poll, well, little question running up on Slido for you all to answer. It's just a very simple one. What sort of topics have you been focusing on the most with your chemistry revision thus far? I know this is all a very important time for everyone watching right now, so have a go at answering that. And then I'm just going to get started into this little introduction bit that we have for the lecture. Hold on, let me. There you go. Alrighty, well, welcome to the ATAR Notes lecture series. This is our final one for any of you grade 12 students going into externals very soon. I know it's a pretty important time of your lives, so thank you all for coming along. Hopefully you find this helpful and interesting. It is going to be a revision lecture, and anybody who's been part of the lecture series will know a little bit about our company, but basically ATAR Notes is a company that's very much focused on helping senior students, so grade 11s and grade 12s across Australia, maximize their marks in the best possible way that they can. We've been doing these online lectures since 2015, and we've been active as a company since 2007. And basically all of us tutors, all of the staff working here are here to do lectures like this. We do classes, we do tutoring, and provide resources to high school students in hopes of helping them out a little bit. So without further ado, I want to talk a little bit first about the kinds of resources that we offer. If you haven't already, please head over to atarnotes.com/register. It's completely free to create an account, and once you do, you get access to all of these resources that are on the screen right now. As part of on our website, we've got access to study notes, discussions, forums, newsletters, helpful videos for all of your subjects, even some subjects that aren't actually being offered as lectures in this series. There are some notes and questions on there for you to check out. Obviously, we do have the ATAR calculator, so that'll give you a rough idea of what your scores need to be to get a certain ATAR that you want. That can be quite helpful with planning just how you want to score on the externals and everything like that. So there are a lot of resources that are available on our website for free. So if you haven't already, I highly recommend that you go ahead and sign up just so you get access to everything. It's never too late to start. Now, as for our website, we actually do have a revamp for our website, which is really exciting. So please don't forget to sign up an account and go around on a little bit. We have updated it so you can find basically everything you need study-wise on here somewhere. And if you're not sure where to start, there is a search bar front and center in the website, so you can peruse for all of your liking. If you are looking for a bit more tailored support, we do have some more resources. Some I'll be talking about at the start of the lecture, later on in the lecture, I'll also be mentioning them. But these are specific resources that we've created. So all of the tutors, most of us are very recent graduates. So we've either come from the 2020 cohort of students or the 2021 cohort of students. I myself am a 2021 graduate, so I graduated last year. And I've also participated in making some of these. We've got three main paid resources that I'll talk a little bit more extensively about later. But the first one is TutorSmart, which is a class tutoring and private tutoring program. We've also got study guides, which I'm sure some of you have seen around the guidebooks and the topic test books and the text guides as well. And probably the best resource that we have on offer is Ed Unlimited, and I'll be talking about that a lot later on, but it's basically a collection of all of our resources put into one platform that you guys can access. So before we start on the actual content part of this chemistry lecture, I just want to tell you guys a little bit about me. I am a 2021 graduate from Ipswich Girls Grammar School, so I'm down in southeast Queensland at the moment, and I graduated with a 99.4 ATAR last year. Currently, I am studying biomedicine at UQ, and I'm first year. If you guys have any questions about uni life, uni applications, med school applications, or just anything about tertiary post grad stuff, please feel free to chuck that in the chat box. In high school, I studied 2 sciences, 2 maths, 2 languages, so English, Japanese, biochem, and then specialist in methods. And then my advice to you is to keep your head up. You're in that final stretch before graduation. So now that we've got that little start, I just want to have a look at, okay, so reaction pathways, yes, definitely. I feel like organic chemistry in general is, because it's such a new topic, you don't really do a lot of it in previous years. It's sort of grade 12 exclusive. It is very much a thing that people are focusing on. Redox is something that I definitely needed to go over in grade 12, just because finding which one, like which compounds would get oxidized and which would get reduced, did my head in. But yeah, it seems that a lot of people are on reaction pathways and organic chem naming. Yes, equilibrium and acid bases are also very important. So it is good that you're focusing on that. I do have one. So over the whole year, I haven't taken any notes, and I'm not sure where I should start studying. I think in that case, start with like a small practice exam. Don't do like a full one, but like, you know how there's like topic revision tests at the back of your textbook? Do one of those. See what you're comfortable with doing and what you're actually struggling with. Start with the hardest topics first and then do a little revision and then move on to the ones that you're more comfortable with. That'll help you plan out your study schedule. Even if you have been taking notes the entire year, do it like a diagnostic test before like really banking down on your study, just to see like this one. What you are more, what's more helpful for you to like focus your time into instead of just revising something that you already know how to do. Okay, so for the rest of the lecture, I have all of you until 6:30, so we've got 2.5 hours together. Today isn't actually going to be content heavy, but if you feel like you're still in the start of your revision, that's okay. Stay tuned. Where I'm basically going to be feeding you exam practice questions, telling you how to approach them. A lot of them are multiple choice, so we're able to get through a lot of little bits, bite-sized bits of content in the 2 hours that I've got with you. Within the lecture, there's going to be multiple choice and short answer. I'm also going to talk about cognitive verbs a little bit, just because I think it's important to know how to answer a question, so you're answering it correctly at the same time. Any questions that you guys have, please use the box down below. There should be like a little question box where you can type in anything. There are designated Q&A times throughout the lecture, so I will be checking in with Slido. If there is a similar question that is already on Slido and it's active, please upvote it so then I can answer it quickly instead of me having to answer, 3 of the same question. And if you're looking for any extra resources, stay tuned. We will be talking about that and we'll be giving you a couple of access codes and things like that. So stay tuned for all of that. So the first topic that we're going to be doing is chemical equilibrium systems. First few questions that I've got for you are multiple choice. So this is kind of going to be like a tag team between you and me. I'll give you guys about 60 seconds, so about a minute to answer. And then afterwards, we'll go through the answers together. I'll give you the explanation and hopefully everything will run smoothly. If you guys have any questions, feel free to pop them in the chat. If I start breaking up or if there's any connection issues, also put that in there so I can see. But without further ado, here is question 1. So which of the following correctly describes the action of a catalyst? 1. Catalysts increase the activation energy of a reaction, but affect the position of equilibrium. B. Catalysts decrease the activation energy of a reaction, but do not affect the position of equilibrium. C. Catalysts have no effect on the activation energy and have no effect on the position of equilibrium. Or D. Catalysts decrease the activation energy of a reaction and have an effect on the position of equilibrium. So I'll give you guys a little bit of time to answer that. This is an ease into the questions. They will start getting harder, but have a go at doing that for me while I get up Slido over here. All right, that should be enough time. With this one, the answer is B. Catalysts aren't a compound or a material or a chemical that is used up in the reaction. And only chemicals that are actively, reacting together affect the position of equilibrium. So something like a catalyst isn't going to have any value or any effect on equilibrium. What it does do is it makes it easier for the reactants to react together successfully. And to do that, you need to sort of have an activation energy. Catalysts lower that, so it's easier for them to react. So following that, the correct answer is B. Here is question 2. So this is also equilibrium related. So with this one, we've got a delta H value that is positive. This means that the reaction is endothermic and that heat energy needs to be absorbed into the reaction to react successfully. In the instance when the temperature is decreased according to LCP, the system of equilibrium will want to oppose that change, so it wants to increase the temperature again. This means that an exothermic reaction needs to occur, and instead of the forward reaction happening, the reaction will happen in reverse. So the answer will be B. And favor the reactants being produced rather than the products being produced of this reaction. Here's question 3. If I am going too fast, also let me know. These ones should be like fairly straightforward. Okay, with this one, another very stock standard equilibrium question. If concentration of NO2 is decreased, the system wants to oppose that change and then increase the concentration of NO2. So it'll favor the production of the product, which is NO2. So the reaction direction will be in the forward direction. So the answer is A. Well, congratulations to anybody who got A. Here's a short response answer. For the reaction above, the following graph can be plotted. What stress has occurred in the system? And label the graph with what is happening at each stage. I'm just going to flip my laptop around so I can draw on the screen. So we've got time 2 here, and then we've got, sorry, I should probably say this is time 1 where the change happened, and this is T0, so the initial conditions. Okay, so with this one, both stages are affected in the same way with this dotted line, so the reverse reaction increasing and the forward reaction eventually decreasing. So therefore, the stress must be a change in temperature or a catalyst. A change in pressure or concentration would only favor one reaction direction only. The forward rate is increased more than the reverse rate. So therefore, we can deduce that this is a change in temperature of some sort, because a catalyst would be affecting both rates equally, and this are different rates. Here, we know that the forward reaction is endothermic. This is a positive delta H value. So the forward reaction was favored more than the reverse reaction. An increase in temperature will favor the reaction that cools the reaction vessel. So it'll favor the endothermic reaction, which absorbs energy. So therefore, the change that has taken place must have been an increase in temperature. So here's our second short response. Very similar graph. Okay. So with this one, very, very similar scenario at the stress, which is where this change has started occurring. You've also got both the reactant and the product concentrations increasing in some way. And so what this means is we're seeing a change either through a catalyst, which has sped up the rates of the reaction, so both concentrations have increased, or we're seeing a change in temperature. Once again, change in pressure or concentration would only favor one reaction direction. The forward rate is increased more than the reverse rate. You can see here is where the forward rate stops, here is where the reverse rate stops. So therefore, the forward rate, therefore, once again, we've got to deduce that this is a change in temperature, because a catalyst would make both of them increase in the same way. The forward reaction here is also remains positive as before, and the forward reaction was favored more than the reverse reaction. So therefore, an increase in temperature will favor a reaction that cools the reaction vessel, an endothermic reaction. Therefore, this is also an increase in temperature as before. Here is question 5. Have a go at that one. I've got a question coming here through Slido asking what would happen if the pressure was increased or decreased. This is what you see happening in this graph right now. So if there's only one of the reactants decreasing or increasing at a time, see here, there is no sharp increase of either. This is indicating to you that this is either a concentration or pressure change, if there's only one sharp line. In the previous graph that we were looking at, the sharp line occurs to both the reverse reaction, so the dotted line, and the forward reaction, so the solid line. This is telling you that this is either a pressure change or a catalyst has been employed. Here, in this one, the sharp line is only exhibited by one compound. So this is telling you that one of the either the concentration of something has decreased, because this is going from high to low, or the pressure of something has decreased. The way that you find out which one has happened is because you've got your equation there. All three of the compounds in this equation are gases, and concentration and pressure of gases is one and the same. So for this, you'll be talking about the concentration of the HI, which has decreased in this graph. Somebody's asking where the lecture slides are. They should be available to download either underneath the video that you're watching this right now, or like somewhere on the page. If not, I can give you a copy of the lecture slides like through a QR code if you can't find them. Keep me updated on that. Is anybody else having problems with finding the lecture slides? Okay. For this question, we're not actually told to ask, to explain what the change is. We're asked how many seconds does the system reach to reach equilibrium. So here, whenever you want to see a system achieving equilibrium, it's whenever these horizontal lines exist. So the first point at which the horizontal lines exist for both of these chemicals is probably going to be here. And if we read that off the graph, that is T is equal to 10 seconds. So this is when equilibrium would be reached for this. Once again, there is a disruption at T is equal to 20 seconds, and equilibrium is once again reached at around 22 seconds. Here, there's another disruption at T is equal to 35, and equilibrium is again reached at T is equal to 40. So there are three answers there. 10 seconds, at 22 seconds, and then 40 seconds is all when the reaction has reached equilibrium. This is calculating the value of the equilibrium constant. Remember that equilibrium constant is our Kc value. That is equal to the concentration of the products divided by the concentration of the reactants. Somebody's saying here, I've learned that pressure is all instantaneous changes, reactants and products. Concentration is one instantaneous change, and temperature is all gradual. That is correct. Yeah, that. So with this one, we've got products as the concentration of hydrogen iodide squared, because we need to raise it to the power of the moles that we've got. We have two reactants, so that is I2 multiplied by H2 gas. So concentration of equilibrium, I'm going to do it the first time that it establishes equilibrium here at T is equal to 10. Somebody's asked what point of the graph do we read? It's not said in the question, so you could either do the first time that equilibrium's been established or the second time that equilibrium's been established. Either way, you should end up with the third, like the correct answer. For hydrogen iodide, I'm going to say that the concentration is 6 squared divided by I2, which is, I'd probably say that's 0.75, multiplied by H2, which is the exact same, also at 0.75. And so when we put all of those together, that is equal to 64.0. Just to make sure that it's all correct, I'm also going to take the equilibrium concentrations at the second time it's achieved equilibrium. So that time, HI is equal to about, I'd say 4.8 squared divided by 1. What is this? Oh, sorry, not 1 point. Probably like 0.6-ish, 0.7. I'm going to say 0.6 times 0.6. That is also equal to 64. So either way, you would have gotten the same Kc value. Here. Oh, we've done a simple question like that. Okay, so here they're saying if the change at T is equal to 35 seconds is due to an increase in temperature, is the reaction exothermic or endothermic? Explain your answer. Okay, so at T is equal to 35, we see a change happening that is decreasing HI and increasing H2 and I2. This means that if there is an increase in temperature, the system is wanting to decrease the temperature by absorbing it up. If you want to decrease the temperature through in a reaction, you're going to be favoring the endothermic reaction here. So if we find out that the forward reaction, which would have produced HI, isn't the one that's being favored, and instead the reverse reaction is going to be endothermic, then we know that the forward reaction, endothermic, then we know that the forward reaction is going to be exothermic, which will have a negative delta H value. Delta H being negative. Actually, I just want to revisit this question based on some of the questions coming in the chat, just because I actually do agree with the person in the chat. I'm looking off an answer sheet for this, and I actually disagree with the answer. Here, you see a global change, a global increase of both the reverse reactants and the forward reactants. If this is happening, this should be a pressure change. I'm sorry for any confusion that's coming through. I'll try and explain this all later. If you've got a temperature change occurring, that won't produce a sharp increase for any of the reactants. A temperature change will only produce gradual increases or gradual decreases, depending on whether the forward reaction is exothermic or endothermic, as we were talking about before. Here, because both of them have increased, as both of the concentrations have increased, we can say that the pressure has decreased. If the concentrations both decrease, then the pressure increases because concentration and pressure of gases are inversely proportional. So here, if we've got both of them increasing, then the side with the fewer moles will be the reaction that is favored. In this case, that is the forward reaction, which is why it's increased. Hold on a second. Oh no, it's a pressure decrease. What am I saying? Sorry. If there is a pressure decrease, then the LCP states that the system will change to oppose the change that's made. In order to oppose a pressure decrease, then the side that produces more moles will be favored, meaning that the reverse reaction will continue increasing and the forward reaction will start to decrease. There you go. There's your answer. So, what stress has occurred in this system? This is a decrease in pressure, causing the system to shift towards the reverse reaction. Reaction to be favored. Sorry about that. Someone's asking what is LPC? LPC is Le Chatelier's principle. LCP, sorry. That I just say LCP for ease. When you're writing your responses in the external, make sure to say the full rule or write the full rule. It's just referring to the law that states a system in equilibrium will seek to oppose the change that is made. Let's go back to this one. Do you have access to the recorded lecture after? Yes, you will. You should have access to the slides, and you also should have access to the recording of the lecture once it's finished. Okay. Got this one. This is a pH calculation, calculating the pH of the solution that results when 40 mL of 0.1 molar NH3 is diluted with 20 mL of distilled water. Here, you've been given the Kb of the base here, and to do this, you need to play around with some of these concentrations. The first step that you want to do is employ the rule C1 V1 is equal to C2 V2, where we know that the volume of NH3 is equal to 40 mL. The concentration of NH3 is equal to 0.1, and we've got a new volume of 60 mL with the 40 and the 20 added together. We now want to find the resulting concentration. To do so, we get 0.1 multiplied by 0.04 liters is equal to C2, which is our X, multiplied by 0.06 liters. X then becomes 0.1 multiplied by 0.04 divided by 0.06. This, if we put into the calculator, gives us 0.0677 moles per liter, or capital M. We've then been given that the Kb is equal to 1.7 multiplied by 10 to the power of 5. The formula for Kb is equal to NH4 the ion, plus multiplied by the concentration of OH minus, divided by the full concentration of NH3, the base. So that is the two ions that the base dissociates into over the total concentration of the base as is. So in the case of NH3, the ratio of NH4 and OH minus is equal. So we've got two of the same being multiplied together, so I can write this as x squared, is equal to 0.0677 minus x. Where I'm getting all of these values is via an ICE table or a RICE table, depending on whatever your school is teaching you. The ratio between all three of these is 1:1:1. The initial concentration of NH3 is what we found over here, which was 0.0677. The change, this would be 0 and this would be 0. The change exhibited by the base is minus x. The change exhibited by the ions is plus x and plus x, once again, because they're all in a 1:1 ratio. So at equilibrium, our base would have a concentration of 0.0677 minus x. NH4 plus ions would have a concentration of x, and OH minus ions would also have a concentration of x. Using all of these values, I've put them into the Kb equation, and now I can solve for x by saying x squared divided by 0.0677 minus x is equal to 1.7 multiplied by 10 to the power of -5. Here we have to neglect or say that 0.0677 minus x is actually equal to 0.0677, as x is only a negligible amount. So therefore x squared is equal to 1.7 times 10 to the power of 5 multiplied by 0.0677, which is equal to 0.00109. 0.00109. We can then say that the pH, where do I have room for this? The pH is equal to negative log, not the pH, the pOH is equal to negative log 10, the concentration of OH minus here. Remember, OH minus was equal to our x value, so this is negative log 10, 0.00109, which ends up being 2.964. So therefore, to find our pH, that is equal to 14 minus the pOH, which is 14 minus 2.964, which is 11.036. I've got here Kb refers to the dissociation constant of the base. This is a ratio that shows you how much of the base, like originally, so we've got a bunch of NH3, which is our base in this scenario, getting split up into two different ions. Here we've got NH4 plus, which is the first ion, and we've got OH minus. OH minus is the ion in this scenario that actually contributes to the pH changing. So this is the one that we want to solve for. Oh, whoops. You can't see the bottom right corner. If I do this, yes, keep them. And do that. Is that a little bit better? I don't know if I can change the position of the camera. Here we go. Hopefully that'll work. There you are. What was I saying before? Okay, so the two ions that NH3 is breaking up into, of the two, OH is the one that we want to find here. The Kb formula can be found in your formula and data sheet in chemistry, And this along with the Ka value is a pretty common formula that we use with acids and bases, particularly when you're asked to find the pH of a solution. Okay, maybe if I try this one. Okay, so that is the answer. Okay, first of all, you guys probably want to set up an equation for this that is nice and balanced. So here we've got sulfuric acid, which is H2SO4, that's aqueous, added together with NaOH, which is also aqueous. Because this is an acid and base, they're going to producing salt and then water alongside it. So I've got the Na2SO4, which is going to be our salt. That plus water. So to balance all of that out, we've got two NAs that I need to deal with. So there's going to be a 2 in front of the NaOH, and then two oxygens on this side. So 2 in front of the H2O to balance out, and that looks to be balanced to me. Then with the NaOH, we've got 38 mils along with a concentration of 0.75 molar. We need to completely neutralize 155 mils of the H2SO4. So we want to find the concentration. To do this, let's find the moles of NaOH first. So to find the moles, when you've got volume and concentration, you multiply those two together. Concentration is 0.75, and remember you want all of your volumes in liters, so that's 38 divided by 1,000 to get that into liters. That would then equal, multiplied by 0.75, I believe this is going to be 0.00285 moles. Now, to find the number of moles of H2SO4 that we require, we need to look at the molar ratio between the two reactants. Here, our molar ratio is 1:2, So therefore, the number of moles of H2SO4 is going to be our moles of NaOH divided by 2. 0.000285 divided by 2. Let's see. Oops, divided by 2. That's equal to 0.0001425 moles. Now, we want to find the concentration of the H2SO4 solution. The concentration is equal to the number of moles divided by the volume. Now, this is going to be 0.001425 divided by 155 over 1,000, because remember, molar, the unit is short for moles per liter, so we need this all to be in liters. So 0.000 by 1,000. 0.001425 divided by, which is 0. No. 0.000. 0.00. Whoops, that's why 0.0001425. It's 0.00092 moles per liter. Hold on. Multiplied by 38 divided by 1,000 is 0. Oh, that's why. This is 0.0285, and therefore this is 0.0285 divided by 2. I was thinking this doesn't seem right, which is 0.01425. So then this is 0.01425 divided by this, which ends up being 0.092 molars. There we go. Sitting there thinking 0.75 and 0.0009 does not seem right. But yes, that's still working for that. This type of question will probably come up in short response or extended response. You wouldn't be getting something like this in multiple choice. It'll probably be like part A or part B of an acids and base related question. But that being said, there are some multiple choice that require this much working. It's not multiple choice questions in the external doesn't necessarily mean that you're getting multiple choice doesn't necessarily mean that you're getting really, really easy questions. There are some in there where you're asked to do calculations with galvanic cells in multiple choice. It happened to me in my external. However, because this is such a standard question with acids and bases, it can be paired with a lot of other questions in like a part A, part B, part C format. So this, you would be more expected to get it in either the short response or the extended response section of the external exam. Can you use the C1V1 formula on this question? Yes, you can. I've just always learned it this way. So if you really wanted to, you're completely fine to use C1V1 is equal to C2V2. Both of them should get you the right answer. And yes, I did have too many zeros. You're absolutely correct. When I was looking at the answer, I didn't think that there would be that many zeros. I think I accidentally put in a 10,000, divide by 10,000 instead of 1,000 somewhere. see. I will move on. Yeah, there's the working using C1V1. Well, this is M1V1 divided by M2V2 and divided by the moles. But that's another way of doing that. All right. I'll give you guys, this is the end of all of the equilibrium questions that we've got. I am going to check in with that graph that we had before, because I see some of you guys are pointing out that this is rate instead of concentration. So here we've got the rate of the forward reaction decreasing. We have the rate of the reverse reaction also increasing. So this is equilibrium trying to be established until here you get equilibrium being established across both of them, where the rate of both the forward and reverse reactions is equal. Then something happens to the system that causes the rates of both of them to increase. But one of the rates is being increased more than the other, and that is the forward reaction. Because both of the rates are being increased spontaneously, I still think that this is a pressure change somewhere. But here, the reverse reaction is starting to increase. Okay. I won't lie to you. I've only ever seen a rate versus time graph once before in chemistry, and that was in my textbook. It's very rare in the external that you'll get a rate versus time graph. Usually it'll be a concentration versus time graph. So I recommend in your study to be focusing on concentration versus time graphs, like the one that was in this question. This is far more akin to what you would see on an external exam on both papers. So yeah, the person who was like rate in first graph, concentration in second graph, you are correct. And I actually think disregard the rate question because this isn't something that you would see. This is, however, something that you would see. So, yes, I do want to keep that. All right, I'm just going to check back into Slido to see if there are any questions that I've missed. Yes, you can use that formula. This person is correct. I don't think it would be multiple choice. It would usually be near the end. However, you might get some questions that ask you to calculate the pH of something, but you won't need to use like a KB formula to find what OH minus is. They would just give you what the OH minus concentration is. KB is referring to dissociation constant of the base. If the temperature increases, won't both reaction rates initially increase before LCP has an effect? Yes, you are correct. Temperature due to collision theory. I think I saw a question like that on here before. Both reaction rates would increase before the system decides to change according to LCP. All I'm saying is that you shouldn't get yourself too concerned with that sort of thing because it won't come up on the external. If anything, you're going to be getting concentration versus time graphs instead of rate versus times graphs on the external exam. No, yes, yes. Okay, right. Before we move on to the next topic, I am going to give you guys a little break. But during this break, I want to introduce you guys to a couple of the resources that we are offering. This is across all of our subjects. This isn't just exclusive to chemistry. But yeah, after this, I'll give you guys a break until about 5:10. So first thing that we offer is weekly classes across all of our subjects. There are some weekly classes still going on. We've got a couple of weeks left where we're going through mock exams and how to cater to the mock exams. I take the biology class on Sunday afternoons. There is also a chemistry class available Saturday morning at 10:30 if you are interested. You do get access to all of the recordings that we've done in the past year, and you get access to mock exams that ATAR Notes has provided as well. If you're interested in a more tailored plan to tackling on externals, we do offer private tutoring. I offer tutoring for biology, chemistry, and methods, but our tutors at ATAR Notes provide a range of subjects, including English, business, accounting, physics, psychology, whatever you need. So if you are interested in just getting that little edge for the next month or so before your externals, I think, go on to tutesmart.com and then book an info call. We should be able to set you up with a tutor who you can do exam revision with. You can bring questions to them, ask them any like focused revision on certain topics if you are interested. So with that being done, I'm going to give you guys around 10 minutes. So at 5:05, we can come back and we can go through some more exam revision questions. Oh. I've got a question coming in asking if you guys are allowed to email me questions. I don't know if I'm allowed to give out my personal email. If you've got a question that's too long for the question box, can you just write part one and then put in as much as you can and then just do like part two and then fit the rest of the question in there? I will have a look at it. I don't know if I can give out my like personal details. Sorry about that. So yeah, just put it in two parts and just say like one or two, and then I should be able to like figure it out from there. Can I give you a link to the lecture slides? Possibly. I'll get them up now. Hold on. Hopefully I should be able to do a QR code. Mm, okay, that should be going across. All right, that should. Hopefully, if you can scan that QR code, you should be given a PDF copy of the slides. I'll see if I can get it to work on mine. Hopefully. Yep, okay. If you scan that QR code, you should be able to get a copy of all of the slides. It is in PDF format, because that's what I'm allowed to give you guys. But if that isn't working, could you also let me know? I'll also see if that is all good. Um, Question 4 on the equilibrium graph. Okay. Okay. This one, if you don't understand it, I think that's okay because you won't be getting something like this. Let me see. Both rates increase because it's a temp increase, and according to collision theory, increasing the temperature will increase the reaction rates of both reactions. Correct. But the forward is favored because it's an endothermic, hence it increases more than the reverse. Yes, you are correct there. But at the same time, I think I've seen this once before in grade 12 and almost never again until I had to look at the lecture slides for today. So the chances of this coming in your external are very, very, very slim. I would actually invest more time into understanding concentration versus time graphs that look like this, or things that you might have seen in your data test practice for chemistry. But yes, your explanation is correct with why the forward reaction increases more than the reverse reaction. So we are almost there. You guys have 5 minutes left, basically. Could I provide the answers? The answers should be on there. If you have a flick through, the questions. What I'll do is at the end of today's lecture, I'll redo the PDF QR code. So you guys will get a new QR code with the answers that I've written on there. And yeah, that should solve the slide problem. Is there anybody on the chat right now who can access the slides? Like, okay, hold on, I'll keep this up. Okay. Were you able to access that through the TuteSmart website, like the little link that you're on right now with, the stream there, or was it through the QR code? Okay, the QR code works. That's good. What I'll do at the end, I'll do like a PDF for like the final lecture slides with all of my annotations on there, and then I'll give you a QR code for that one as well. And then hopefully that will solve the slide issue. I'll just wait another 3 minutes till you guys are back. Okay, perfect. It should say chemistry slides and you should be able to download it. Okay, the other people are only getting it from the QR code, so I don't know what's happening. Hopefully, you should be able to come back. All right. I want to wait until everyone gets back before starting with the next couple of resources, but these next 2 resources that I'm going to talk about are probably the most important ones that I can give you through ATAR notes. I know if you guys are looking for any practice exams and things like that, try joining a Facebook group or like an Instagram group chat for QCE Chemistry. Some really, really nice people are on there sharing practice exams. That's how I got a lot of mine in grade 12. I definitely recommend it to some of you guys as well. Also, it's a nice way of just interacting with people doing your subject. You can put questions on there. So even if you don't have a tutor, you can interact with people who might be able to answer your question. If not, please go to the ATAR Notes forum and stick a question in there. There are moderators and tutors looking at questions like that, so we can come in and help you if you've got any one-off questions to go through the forum. Okay, any tips for a grade 11 student starting grade 12 next term? Wow, wait, what are you doing here? I'm going to assume that you're doing grade 12 chemistry a year early and you're not just here doing external prep at the end of grade 11, because that's a lot. I think tips, if you're doing grade 12 next term and you've got a spare subject, use it to your advantage. Don't just muck around in it. I know a lot of my friends in grade 12 this year have done spare subjects and are because they did a grade 12 subject in grade 11. They use it to do light revision, like preparing for all of their subjects instead of doing 5. I think starting off grade 12, especially if you're doing very content heavy subjects, with interacting with the syllabus and doing up a good set of notes is a good way to start, because then you're not cramming at the end to revise everything, and you can just focus on questions and external prep when you need to focus on it, instead of trying to cram in notes here and there at the end of it. That would be my best advice, like starting early and getting a really good set of notes according to the syllabus done. All right, that is a 505, so I'm going to start again. As many of you who would have interacted with ATAR Notes would know that we do a massive range of study guides that come out every year. We have currently a bookshop offer to all of you who are participating in the holiday lecture series. So if you want any of these guides in person, and this includes like not just chemistry, like physics course notes, bio course notes, and the text guides, you can use the code 15SEP on checkout to get 15% off. I would actually recommend, if you're an English or literature student, genuinely get the text guide. It was really, really helpful for me. I did Macbeth in grade 12, and a lot of one of the paragraphs that I did in the external itself was a point that I got from the ATAR Notes text guide that I just rewrote and memorized for the external. So genuinely, these guys are really, really helpful. The topic test books, I know there's one coming out for methods, there's one out for chem, there's one out for specialist. They're also really, really helpful because it's all exam questions organized topic by topic. So that's really good for targeted revision or focused revision sessions. So if you are interested in getting the in-person books, definitely use the code 15SEP for a little bit of a bargain. However, of all of the resources that we have at ATAR Notes, the one that I recommend to nearly every grade 12 student is probably going to be an Unlimited. This is an online platform that gives you access to every single one of our text guides. So all of the topic test booklets from every single one of the states, all of the course notes from all the states as well, across all of our subjects. And it's this one massive database of resources for you. And for the next 21 days, so basically for the next month, you can get it for free if you use my code, Amundi QCE. Before we go on, I just want to show you this very, very quickly because it probably is, if I could recommend any resource that you buy, this would probably be it because it's so expensive. ATAR Notes has also recently partnered up with the exam paper company Neep. And I can tell you firsthand experience wise, Neep was probably the company that did the hardest, standard wise papers. So they were really, really helpful. So there's stuff in here for grade 11, there's stuff in here for grade 12. What I would probably the most useful is the text guides for English, but that's just because I found it really, really useful. The topic tests are also fantastic. Most of these are for New South Wales, but integration in New South Wales isn't going to be any different to integration in Queensland, so you can use them across both. There is the QCE topic test for chemistry, physics, methods, and I believe we're getting a specialist one under the way. Furthermore, if you type up practice papers, you can get the VCE NEEP papers, and they're uploading the QCE NEEP papers as well. But they're really, really useful. So I definitely recommend, if you're going to get any resource from today, buy it Unlimited. It's so worth it. And it's free. So there's not even much buying going on if you use the code, that is. But yeah, 100% recommend you getting these. Alrighty, moving on to our topic 2, which is oxidation and reduction practice. I keep clicking from the beginning. Here we go. Balance the following reaction under acidic conditions. Oh, you might be asking, what does acidic conditions mean? It just means that the reaction it doesn't actually mean anything. You just need to balance it. But remember, with balance, the trick here with balancing redox reactions is that you've got to pay attention to the O's and the H's, and then add H2O where to balance out the O's across each of the sides of the reaction. Doesn't really matter if it's acidic or alkaline. I don't think it makes a difference. To this one.
Are you done?
So for your rules here, you want to add H2Os to balance out oxygen. You want to add H plus to balance out H's. And you want to add electrons to balance the charges. So here, the only place where I've got a O that I need to balance is in the Cr2O7. That's 7 O's that I need to make up for, so I'll be adding 7 H2O onto the product side so that that's all balanced. Now I end up with 14 H plus on the right hand side through these two. So I've got to add 14 H plus onto the left hand side to balance all of that out. Then I need to make sure that all of the ions are balanced. I've got one Fe, that's fine. Two CRs here, so this is going to be a 2 CR3 plus. And that looks to be balanced atoms wise. Now let's balance a charge. So here we've got 14 plus from the H's. We've got 2 minus from the Cr2O7. I've got 2 plus. So these all added together, the 2 minus and the 2 plus cancel each other out. So this becomes 14. We've then got 2 loads of 3 plus. So this is plus 6 here. We then have 1 load of 3 plus, which is 9, and then 7 H2Os. H2O is neutral, so it's 0. So we've got 9 over here. If I'm adding electrons, I have to add it to the larger side so that it becomes the smaller side's number. To get from 14 to... No, hold on a second now. Once again, it says here that I've got to add 6 electrons, but it looks to me that I've got to add 5. So, yes, 5 electrons onto the end of the left-hand side. And so the final reaction becomes 5E minus plus 14H plus Cr2O7 2 minus plus Fe2 plus reacts to form 2Cr3 plus Fe3 plus 7H2O. And then that should be fine. If you've got any final elements that cancel each other out, then you should be able to cancel out, but this doesn't look to have anything that cancels out, so we'll be going on. The only thing that cancels is this. Okay. There you go. So this is another very similar question. Balance the following reaction under acidic conditions. Okay, I've got a question coming in about how the Cr2O7 2- in the formula book has 6 electrons. That is true. You need 6 electrons to power the Cr2O7 redox equation, right? But if you're looking at the Fe2 plus to Fe3 plus equation, there should be an electron that comes up on this side. If you've got 6 electrons coming in on one side and then 1 electron is left over in the final side, altogether only 5 electrons are being used up on the left-hand side. So that's why in the answer there's only 5 being produced there, even though technically speaking, it's that 6 electrons go into the equation and 1 electron gets put out. Oh, oops. The 6Fe, what they've done here is they've taken both individual equations, the half equations for both of these. So the half equation for Cr2O7 is equal to 6E plus 14H plus Cr2O7 is equal to 2Cr3 plus 7H2O. That is from the formula sheet. You also get the other half reaction, which is Fe2 plus forming Fe3 plus E minus. To balance both of these together, we see that there's 6 electrons on this side, but only 1 electron on this side. So to equalize the charges, you've got to multiply this by 6. This ends up being 6 Fe2 plus reacting to form 6 Fe3 plus 6 electrons. Then, theoretically, you put them together so that the charges cancel each other out, resulting in 14H plus Cr2O7 plus 6 Fe2 plus reacting to form 2Cr3 plus 7H2O plus 6 Fe3 plus, where technically there would be 6 electrons going in and 6 electrons going out, but because the 2 electrons exist on both sides, they cancel each other out. That's what the answer is saying. Though, with the following equation, with Fe plus HCl is equal to HFeCl4 plus H2, there are quite a number of distracting ions in this that poses a lot of problems to this question, especially regarding the Cl. The key to actually solving this problem is to eliminate everything that isn't being oxidized or reduced. So when we're looking at the ions that are coming into play here, we've got Fe solid turning into an Fe ion of some sort. To figure out what that ion is, we've got 1 plus from the H and 4 minuses from the Cl, with the overall charge of the molecule being 0. So minus 4 plus 1 ends up being minus 3. In order to get it back up to 0, this Fe will have to have a plus 3 charge. So now we know that we're dealing with an Fe solid turning into an Fe plus ion. That's one thing that's happening. And because the oxidation state is increasing, we know that this is the thing getting oxidized. Then, with the Cl, the oxidation state of the Cl remains constant. Cl always is -1 in this case. With H, however, it ends up being from +1 here to 0 in this H2. So we've got now a H plus ion turning into H2 gas somewhere down the line. So this is the thing that is getting reduced. Now we can set up our two half equations now that we've deduced what's actually participating in the redox reaction. So with our half reactions, the first one is the oxidation reaction where Fe solid is getting oxidized into the Fe3 plus ion plus 3 electrons. For H plus, I've got H plus somehow forming H2. To balance this, I've got a 2 in front here, balanced out with 2 electrons to neutralize the 2 plus charge there. And because we've got 3 electrons on this side and 2 electrons on this side, we need to make sure that the number of electrons are equal on both sides. So I'm multiplying the top reaction by 2 and I'm multiplying the bottom reaction by 3. This ends up with 2 Fe solid is equal to, reacts to form 2 Fe3 plus 6 electrons. And then on the bottom, we get 6 electrons plus 3 H plus, reacting to form 3 H2. I'm going to assume that's a gas. I think that's a gas there. So putting that all together, I've got 2 Fe solid plus 3 H plus, ions will be aqueous, reacting to form 2 Fe3 plus, which is aqueous, plus 3 H2 gas. And that ends up being your final balanced equation. If you were to take it one step further, you can then add all of this back into the original up here. So with 3 H pluses now being added, we've got 2 Fe solid. Sorry, we've got Fe solid plus HCl reacting to form HFeCl4 plus H2 from our non-aqueous elements. So this is the 3H2 here and the 2Fe here. This is what we've got to pay attention to when balancing this equation. So all in all, I've got 3 H2s being produced somehow and 2 Fe's going in. I use these two to then balance out the rest of the chemicals in this equation, because these are just ions floating around. They don't necessarily correspond with the total number of hydrogens in the components itself. So I've got 6 H2 all in all, and I've got 4 Cls coming in from here, but if I was to put a 4 there, then that would be 1 H plus 6 H's, so that's 7 H's. That doesn't work out. So I'm thinking I put a 2 in front of this HFeCl4. So there's 2 H's and 6 H's here. Put a 8 in front of here and see if the Cl's balance out. Here I've got 2 times 4 Cl, so that's 8 Cl, and 8 Cl on the left-hand side. So if you were to leave it like this, you still would have gotten the question correct. If you wanted it to take one step further and relate it back to the original equation, you can balance it like that as well, by using the 2 non-aqueous substances to balance your original equation. That one's a hard one though, if I'm being honest. What's this one? You do split it into half equations and balance them. There's 6 in and then you multiply by the 6. Yes, I made a mistake in the previous question. The correct answer should be this one. With these two, you want to split it up into the oxidation half equation and the reduction half equation, and then balance the electrons from there on. There are some cases where they give you the oxidation half equation and reduction half equation non-balanced, and you have to add the H2Os and the H plus in there. But because this is already in the formula sheet, you can see that there's 14 H pluses and 7 H2Os being added in there. That was my mistake. Sorry about that. And yep, that's correct. All right. Here's another one to try. Remember, you want to find your your 2 half reactions first, balance the electrons, and then put them all together at the end. Okay. With this one, you can see that the NO3 minus is going to be converted into this NO, and the H2O2 is going to be converted into this O2. So this is the 2 skeleton equations that we're going to be dealing with here. In order to balance out O's, sorry, this is NO by itself, and then H2O2 forming O2 by itself. In order to balance out our O's, we want to be adding H2O molecules, and then in order to balance out the H's, we add H+. Here, I've got 3 O's that I'm concerned with. Here, I've only got 1. So to balance that out, I need to add 2 H2O molecules, so that balance out the O's. Down here, I've got O2 and O2. That seems pretty balanced to me, so I don't need to add any more O's in the bottom equation. With H's, I now have 4 H's on the left-hand side here, so I add 4H plus to the right-hand side. And then with the bottom equation, I've got 2 H's, so I've got 2H plus onto the right-hand side to balance those out. Now we use electrons to balance out the charges. Here I've got 4, so plus 4 from the H plus, minus 1, ending up with plus 3 in total here. I've got 0 on the left-hand side. So to balance that out, I add 3 electrons to cancel out the plus 3 from the left-hand side. Here, I've got 2 pluses coming on the right-hand side. And so to neutralize that, because our left-hand side is 0 here, I'm going to add 2 electrons to get rid of that positive charge. Those are our 2 half equations now. So because we've got uneven numbers of electrons, we want to be equalizing them. To do that, I multiply this by 2, this reaction by 2, and I multiply this reaction by 3 to hopefully get 6 electrons on each side. So I'm getting 6E plus 8H plus 2NO3 minus, reacting to form 2NO plus 4H2O. Now, with the second reaction, I've got 3H2O2 reacting to form 3O2 plus 6H plus 6 electrons. Now, when I put that all together, the electrons are cancelling out. So that is giving me 8H plus 2NO3 minus plus 3H2O2 reacting to form 2NO plus 4H2O plus 3O2 plus 6H plus. And that ends up being everything. If you want to take it one step further, you can actually combine the H and the NO3 together. So you end up with 6H plus 2HNO3, which is nitric acid, plus 3H2O2, reacting to form 2NO plus 4H2O plus 3O2 plus 6H plus. And because this 6H plus is common to both sides, this ends up being your final equation. That is balanced. Okay, let's go on to the next question. Yep, 2HNO3 plus 3H2O2 it reacts to form 2NO plus 4H2O plus 3O2. There we go. Here, okay, I think we can skip one of these. All right, try out this question. Can you cancel out the hydrogen ions? In this question, you can cancel out the hydrogen ions if they are common to both sides. So because I had 6H plus on the left-hand side and 6H plus on the right-hand side, and they were equal, then I could cancel them out. If, say, it was like 8H plus and 6H plus like before, you could cancel out this 6H plus, but you would be left with 2H plus on this side. You are allowed to cancel out anything that is common, providing that you're still following the rules of maths. Here, what I've done is just I've combined the H and the NO3 so it becomes a stable compound like nitric acid. And that's why I was able to cancel out all of the H plus because both of them ended up being equal leftover amounts. Oh, sorry, I'll put up the other question there. Okay, with this one, we've got two half equations being given to us. We've got one with 5 electrons and the other one with producing 2 electrons. To balance them, I'll have to take the first one and multiply it by 2, take the second one and multiply it by 5. So in total, I get 2 MnO minus, MnO4 minus, plus 16H plus 10 electrons, producing 2 Mn2 plus 8 H2O. Now the cell potential stays the exact same. With the second equation, I end up having 5 SN2 reacting to form 5 SN4 plus 10 E minus. Now everything else seems to be balanced, so I can just combine them together now that the electrons are balanced. So I've got 2 MnO4 minus, this is aqueous, plus 16H plus, which is also aqueous, plus 5 SN2 plus, which is also aqueous, reacting to form 2 Mn2 plus, which is aqueous, plus H2O, which is a liquid, plus 5 SN4 plus. To find out what my cell potential value is, E note cell is equal to the E note at the cathode plus the E note at the anode. Our anode reaction is the SN reaction as the oxidation state has increased. So this E note is the one that we're plussing. Oops, 0.15 volts. This is the anode. Our cathode is the one undergoing oxidation because the electrons are on the left-hand side. That's the other way that you know it. So the E note cell value of 1.51 volts is our cathode value. So this becomes 1.51 plus 0.15, leading to 1.66 volts. Now, because this is a positive value, this is how you know that it is product favored, which is the third part of the question here. If this was a negative value, then it would be reactant favored. That's just... and that is the full reaction put together. Honestly speaking, this would have been a 4-mark question, I reckon. One for putting together the balancing the electrons, one for putting together the full balanced equation, one for calculating the cell potential value, and one for calculating whether it is a reactant product or reactant favored or a product favored reaction. There you go. All right. We're up to the organic chemistry topic. I'm just going to check in and yes, keep my ink annotations. Check into Slido to make sure that everything's okay. I think I answered this one. Can I carry out the hydrogen ions? Yes. What is happening? I think it's just reloading. Oh. Sorry about that, guys. Hopefully. Yes. So can you cancel out the hydrogen ions? Yes, you can. I've tried to memorize all of the reaction pathways and their conditions with flashcards, but it isn't sticking. Any advice? The way that I did it was I basically went and created like a massive pathways map. Like it had, or it started with like alkanes, went to alkenes, haloalkanes. Down here was alcohols to carboxylic acids, and everything was connected to each other. I used like different colors to represent different types of reactions. So I think elimination reactions was one color, addition reactions was another, oxidation, substitution, etc. And then on top of all of the arrows, I had written the reaction conditions, like whether it was at 400 degrees Celsius, whether there was a catalyst or anything like that. Um, just so everything was always on one big map. Now, there is a similar example of a reaction pathways map in the QCEE syllabus that you can have a look at. I'll pull it up. But it's pretty basic. It doesn't have the reaction conditions on there or anything. So I recommend using that as a start, like a guide, and then adding the reaction conditions and putting in all of the catalysts and linking everything up together. That's so adding like potassium dichromate or acidified potassium dichromate, potassium permanganate or acidified dichromate to the oxidation arrow as an example. That's something that you can do. The second thing that I would recommend for reaction pathways is just doing questions on them. They are pretty repetitive. Almost all of the ones that I've seen have the oxidation of a primary alcohol to a carboxylic acid, and then that carboxylic acid being combined with the same alcohol to produce an ester. That question has come up nearly 4 times across the practice exams that I've done. So if we scroll down to Unit 4 in the syllabus, I can't quite remember what page it was on, but I know that it's in here somewhere. This is biology. Whoops. Here it came. Try what you should do. Get a question that is on reaction pathways. Do up a full solution with the flowchart. Put the flowchart away and then redo the question without it. See what you remember. See if you remember the catalyst. See if you remember the temperatures, the pressures, and everything like that. And then whatever you don't remember, fill in with another color. Always build upon, like, use the flowchart as a guide, but make sure that you're reattempting the question without the flowchart to prove to yourself that you know how to do it without one. It is hard, and it by any means, like, it's not easy at all. And a lot of people struggle with reaction pathway questions, which is why they tend to be quite repetitive in the external. If I go down, come on, it is here somewhere. Hopefully. The one here. If I go down and say this pathway from an alcohol, a primary alcohol to a carboxylic acid, comes up in like 3 out of 5 of every single reaction pathways questions. It is quite a common one. Another one that I've seen is like a haloalkene to an alkene. Alkene to an alcohol sometimes comes up, but oftentimes it's either esterification or oxidation of alcohols. So on these arrows, I would write the catalysts and the temperatures and the pressures and everything, and I'd made sure that it was like fully complete. After I had done that, I would seek out reaction pathways questions. There are some in your textbook. There are some worksheets that you can find. Try going through practice exams and finding them and like singling them out and doing them. And hopefully that'll help. That's really the only way that I can think of doing them. If flashcards hasn't been for you, probably resort to exam questions. Okay, is E note cell equal to the E note of the react? Okay, yes. It's both. Honestly, you can do its minus if you're doing it off the QCEE formula and data book. So if I scroll up to the potentials diagram, it's this value minus whatever the value on the table is. If you're using the value on the table, it's a minus. If you already flip the reaction around, so you know how the E note of the cathode or E note of the reduction minus the E note of the oxidation. If you've taken the oxidation equation from this table and flipped it around so that the electrons are on the correct side, then you should be plussing it. If I'm taking this value, I'm minusing it. If I'm taking the negative version of this value, because I've already flipped it around, I'm plussing it. It's very confusing. And if you've learnt it as minus, continue doing that. Don't let me confuse you. I learnt it as plus. So that's the reason I do plus. I honestly think it's easier if I had learnt it as minus because all of the values in the book are what you should be using it with the minus equation. So it's like both. I know that's a bad answer, but it depends on what version of the cell potential you're using from the formula and data book. So yes, we've done this one, Okay, I'll talk a little bit more about the mock papers later on. For now, we've got to get through organic chemistry, so everybody's favorite. Here's your first question. Write the name of the hydrocarbon printed below. These should be pretty okay. Like I'm starting off quite easy. And then we'll get on to infrared later on. Okay, so nice and simple. This is just a straight chained alkane. It doesn't have any double bonds. It doesn't have any functional groups. It's purely just carbons and hydrogens attached to each other. So it's not going to be octine or octene off the bat. Now we've just got to count them properly. So if you counted 8, you are correct. The prefix for 8 is octane. So oct. So this would be octane, the alkane with 8 carbons. Let's go on to question 2. Slightly harder. This is a little bit more branched. So with this one, once again, no functional groups, no oxygens, no funky things happening there. This is just a branched alkane. The trick with this is that you find the branch with the longest number of carbons first, and that'll be your main carbon chain. So I'm thinking that it's this one right here with, wait, hold on a second. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Whoops. It's this one. Like so. Now we've got a methyl group here. We have another methyl group here. And we have a ethyl group here. So we've got 2 options for this. Either dipropylpentane is immediately out. I've got dimethylhexane also immediately out because the main chain is 7. So between us, we've got to figure out whether it's 4-ethyl-5,6-methylheptane or 4-ethyl-2,3 dimethylheptane. Now, immediately we know which one is the correct answer because if there are two methyl groups, the prefix di must exist. So your answer is C. The other way that you know it's correct is you also want to be naming with the lowest numbers that you can name. So 2,3-methyl is more correct than 5,6-methyl, even though technically speaking, this would be 1, 2, 3, 4, 5, and 6 if you were numbering from this side. However, because this side is the side closer to all of the branched groups, you're going to start carbon number 1 with this carbon. So it becomes 2, 3 dimethyl, 4 ethyl. Ethyl coming first because it's in alphabetical order. But that is why C is the correct answer here. Here's another one. This time we've actually got a functional group to talk about. Okay. With this one, we've got COOH as our terminal functional group. This is the functional group of a carboxylic acid. Acylic acid. Just to make sure that nothing else is going on, to make sure it's not an ester, this is just going to be carbons and hydrogens left over. So now that an ester is out of the options, we can say that it is carboxylic acid. Aldehydes would be COOH. Ketones are COO in the middle of the chain. Okay, there you go. There is question 4. Okay, nice and simple once again. There's just an OH, a single OH connected to a carbon here. This is a type of alcohol, so I can eliminate B and D immediately. A primary alcohol is one on the terminal carbon, so the first or the last carbon of the chain, and none of these are the alcohol. The OH is definitely not connected to any of these. So this becomes a secondary alcohol, one that is connected to a carbon that's connected to another 2 carbons, which is where the secondary comes from. So this answer is C. Okay, with this one, we're wanting to rank them according to their boiling and melting points. High boiling points mean that you're going to be having very strong intermolecular forces. So that's IMFs. Low boiling points are lower intermolecular forces. So let's compare the intermolecular forces of these 3 molecules. I've got low boiling here. Here on the left-hand side, I've just got straight-chained carbon, no O's, no hydrogen bonding, no nothing going on. This is probably just going to be forming dispersion forces, so they are quite weak. in terms of this one, I've got a C double bonded to an O. This is a polar bond, so this will be forming a dipole. And then finally, I've got a C double O on top of an OH. This forms hydrogen bonding, which is the strongest, along with a dipole. All of these would be also forming dispersion forces. And this would also be forming dispersion forces. So the strongest one by far is the one on the right-hand side. So this one would have the highest boiling point. The second one would be the middle, and the left-hand side would have the lowest boiling point. So your answer is E. So solubility in organic solvents. Organic solvents are like heptane, oxane, very non-polar. And so like dissolves like is the general rule that you want to be following with solubility. In something like with this molecule, with its hydrogen bonding, dipole-dipole interactions, and dispersion forces, it's probably going to have very weak solubility because this one is so polar compared to the solvent. With this one, because it's only dipole interactions, it's not as strong. It'll still have weak solubility, but not as weak as the one on the left-hand side. The one on the right-hand side here seems to be a non-polar object as well, so this will be a very high solubility with an organic solvent. So your highest solubility is going to be the one on the left. The middle solubility is going to be the one in the middle, and then the weak solubility is the one on the right. I'm thinking B is the right answer. Okay, good. Okay, have a go at question 7. So here we've got HCl reacting with the following compound. This means that this double bond is going to break and a halogen will be invited into this carbon chain. So if we're adding HCl onto here, this is a substitute. This is a addition reaction, I think, where we'll have CH3. This CH bond will be preserved, but instead of this having a double bond, it'll open up and form Cl there, or with the H, and then CH2. According to Markovnikov's rule, we're either getting we've got CH3 happening there. The H of the HCl is more likely to bond with the C that's already bonded to more H's. This C right here was only bonded to one H before. This C originally had two. So the H from the HCl is more likely to join that final C on the end there. And the Cl is more likely to go in this middle, this carbon number 2 on this chain. So your more likely compound would be 2-chloropropane, which is number B. What type of reaction is utilized to form disaccharides or polysaccharides? Alrighty. Here we've got saccharide synthesis. So this is taking a monosaccharide and adding it together to form either a disaccharide or a polysaccharide. With nearly all of these organic molecules, so the proteins, the lipids, the monosaccharides into disaccharides, it's always going to be some sort of dehydration reaction. So you're taking a H off of one of these sugars. Remember, monosaccharide is a sugar, and an OH off of another sugar so that they can attach together and form a disaccharide. A H and OH, the things that were broken off, then come together to form H2O. This is dehydration because it's losing water. And so A becomes our answer here, dehydration synthesis. All right, moving on to some of the harder-ish. I say harder because I struggled with IR in grade 12, but identify which of the following compounds creates the IR spectrum pictured below. Now this one, you can use the little cheat sheet that's in your formula and data book if you've got it on you. So for our options here, we've got an alcohol with its OH group. We have a ketone with the carbonyl carbon in the middle of the chain. By looks of it, we've got an aldehyde right here. And we've also got something with an NH2, so that's an amine. Now, if we look at the IR spectrum here, we see a peak around 3000. That honestly is just representing the CH1. It's not actually that important. We also see a small peak at around 2100-ish. This actually signifies a triple bond. Not just any triple bond, the triple bond between a carbon and a nitrogen. This is very, very characteristic of a nitrile, which is what we have for option E. So option E is our answer here. We've got another IR spectrum equation for... Is that not just the same thing? Or did that change? Yeah, I think I've copied and pasted the same question. There you are. There's a new. Sometimes, however, when we're dealing with IR, you can't just rely on the formula and data book to help you get through with this one. There are some compounds that have really, really distinct shapes. This one being an example of that. If you see a smooth peak here that looks almost like a really, really thin bell curve, like with no hairy bits, with no pointy bits like this, it's almost a telltale sign that this is going to be an alcohol. Similarly, if we've got one that looks a bit like a dip around this area, so higher than the 3000 area, but it's got like really, really, really scraggly edges and it goes up a little bit like this. This is a carboxylic acid. Remember, alcohols are smooth, carboxylic acids are very, very rough. They appear around the same end of the IR, but their shapes are very, very different, which helps you identify them a little bit better. Right, now, because this is really, really smooth, I would say that this is A, which is our alcohol. Yes, so A. Nice. All right, have a look at this one. So with this one here, I've got a peak around 3000, which is virtually useless because that refers to CHs. However, along with that, we end up with a peak around this 1700 mark that seems to be quite sharp. So this is signifying a C-double-O bond. Now, what we also see around the 2700 peak is an extra little sharp peak here, signifying that a CH bond belonging to either an aldehyde, alkane, alkene, alkyne, or amide exists. So if we're dealing with this CH on the end here plus a CO, I'm thinking that this is going to be an aldehyde rather than our ketone here. If this was a ketone, then this would look something a little bit more like this. It wouldn't quite extend to the 2700-ish area. I've got a couple more of these for you guys lined up. It's question 12. Actually, no, this is our final IR, and then the next one is mass spec. So with this one, you're sort of given two options here. Either the amine or the ketone. There is a very distinct characteristic of amines that you can find very easily on IR, and that's this fang that occurs in the plus 3000 area. Around 3100, if you see a double peak that represents a fang-looking shape, that's going to be an amine. Remember, hairy beard is for the carboxylic acids, smooth curve is for the alcohols, fangs are going to be for your amines. So this ends up being D, which is your amine, rather than your ketone. Here. Sorry, I've just got a question coming up. How do I recognize that this is a ketone and not an aldehyde? Here, I've got one large peak around the 1700 area. According to your formula and data book, that represents a C-double-O bond that belongs to either aldehydes, carboxylic acids, esters, or ketones. Then we also see that there is a CH bond happening around 2700 to 3100, which is happening around here. This CH bond, it's the third last one from the top of the third from the bottom of the infrared table. That CH represents a CH bond only found in alkanes, alkenes, alkynes, aldehydes, and amides. So if I've got a C-double-O bond by itself, remember if it's a carboxylic acid, which also has a carbonyl, it'll have this hairy beard form around this section, and that section is completely blank. So if we compare these two together, if I've got a CH and an CO happening, then this has to be an aldehyde, not a ketone. Because of that peak at the 2700 to 3100 component of the IR spectrum. So there's, oops, have we done this? Yeah, so we're doing the mass spec now. for this mass spectrum, the way that mass spec works in grade 12 is when you put all of these organic compounds through the mass spectrometer, they'll be separating into certain components, certain ions that can break off easily from the original compound. With pentane-3-one, that is a ketone with the carbonyl on carbon number 3. In total, we've got 5 carbons here, so let me just draw this out. We've got 1, 2, 3, 4, 5. Carbon number 3 will have COO, and the rest will be followed by H's. Oops, H doesn't go there. 1, 2, 3. We've got an 86 peak first. Now, this should represent the molecular weight of the compound. Let me just check that very quickly. That's 5 times 12, which is 60, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 70, and then 16 from the oxygen, altogether forming 86. So the peak at 86 represents the molecular weight of pentane-3-one. We then have a 57 here. Now, the 57 could be made up of one, divide that by 12, that's 4 carbons, 40, what's 57 divided by 13 going to be? If I take this break here, I get 16 plus 36 plus 1, 2, 3, 4, 5. What does that end up being? It's 57. So if I divide 57 by 13, the reason why I do this in mass spectrometry is because carbons is 12, and any H that's attached to a carbon will make a group of 13. If you divide your peaks by 13, you can usually deduce how many carbons belong to that particular group. Now, in this case, I got like 4.8 something. However, it's very hard for a group of 4 to break apart in this ketone because of this carbonyl here. The carbonyl, the C and the O from the carbonyl usually like to stick together. And so that's why I decided to experiment with the break being here with 3 carbons, 1, 2, 3, 4, 5 hydrogens, and 1 oxygen. Those being added together produces 57. So this peak is made by the ion of 3 carbons, 1 oxygen, and 5 H's breaking apart. So that's what that number is corresponding to. We also have a 29 here. Usually this 29 will be whatever is left over from the highest peak from the 57, but let's just check that to be sure. First I've got 2 12s, which will make 24, and then 1, 2, 3, 4, 5 hydrogens, which will boost it up to 29. So this is the latter half of that molecule. That's C, C, H, 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 H. Being formed here. And these are the 3 main peaks being formed from this mass spec. Okay, after this, I believe, yep, base peak and then peak at 29. Awesome. Alrighty, I do have another break for you guys. Isn't it an alkyne and not a nitrile? The formula of the book says. Oh, hold on. Let me check with this one. Oh, yes, that is not a nitrile. That is an alkyne. That's a triple bond C triple bonded to a C, not a C triple bonded to an N. That's my mistake. But that peak should occur around the 2100 zone. C triple bonded C bonds, yes. Either way, the answer is E, the triple bonded one. Do we need to identify nitriles from an IR spectrum? I don't think so. I think that's just my bad. Sorry about that. Anything, yes, it is an alkyne, not a nitrile. Anything with a triple bond should be a C triple bonded to a C and not a C triple bonded to an N. If the formula book doesn't mention it, you don't need to know it for the external. I do know that for a fact. Hold on, going back. I will give you guys another break. This time we'll give it a shorter one, maybe until 6:20, and I'll go and answer some of the questions from the Slido coming through. The biology mock paper had very vague questions on it, and I wasn't sure what they were looking for in my answer. Are the externals better than the mock exams? Honestly speaking, no. Biology in particular suffers from this quite a bit, but the QCEE marking guides, because ATAR has only been around for a couple of years, they're still very much working on how questions should be answered. Chemistry, they're a little bit better with it because it's so much more maths-based. Like, it's harder to stuff a question when you're using a formula. Whereas with biology, there were some questions, even in my external, which could have been interpreted in a certain way. But the marking guide had a very strict, like, mark allocation scheme. So yes, there are vague questions. The way to overcome that is to see a question. If you're not exactly sure what it's asking, write 2 alternative answers down. Now, I actually did this. I didn't do this in the external. I did this in my mock because I had no idea what the question was asking me. Try and write as broad of an answer as you can, so at least the marker would be able to see something and give you... Have I? Hello? Have I frozen? Hello? Nope. I don't know. I don't know if I'm still going. mm, Okay. Hopefully that will clear up. Hopefully. But yeah, if you've got any... Okay. Oh my god, that actually scared me. I'm very, very confused then. All right. If there are any vague questions, just answer as broadly as you can, because then the marker who's looking on a very strict marking scheme, if you've ever interacted with the marking schemes for biology, they are very specific. The marker who's looking at it can still give you the marks that you have written down. It is still a work in progress thing because the ATAR is still so new for Queensland. But for this subject, for chemistry, it is a lot less vague. You'll be getting a lot more doable questions. They'll still be hard, don't get me wrong, they will be difficult, but they'll be more doable than some of the bio questions are. So I hope that answers the question. It is a hard thing to answer. Hopefully for you guys, because it's the 3rd year that they're doing this, it'll be a little bit better than it was for the previous 2 years. But yeah, I don't think you're going to see that problem with chem too much. How do I deal with procrastination? That is a good question. I feel like mocks really helped. For those of you who have received your mock exam results, it's quite a humbling experience. That was certainly good motivation for me. I also had a study group with a bunch of friends that kept me on my toes because we were all holding each other accountable. If you know that you need to be doing well for these externals and, burnout and procrastination is getting to you, find someone who can hold you accountable and do some study together, providing that it is productive. If you're just mucking around, well, then you don't have that kind of time to waste at this point in time. So if you've got a trustworthy friend or like a classmate who wants to, do as well as you do, or even better, then I invest getting your peers help. Other than that, I think it's just a matter of writing down to-do lists, things that you need to do, and just getting them done. It's hard, don't get me wrong. You do start to feel really, really burnt out around this time of year, but at the same time, you've got 1 month left until everything's complete. So there is that silver lining to look forward to. And then you can, after graduation, you can go and party till the cows come home. Any specific shapes or tips that you have for dealing with that? I think it's those three that I always remember. The fangs were the amines, the beard was the carboxylic acid, and the tongue, the smooth curve, was the alcohol. Between those three. Okay, we are at 6:20, so I've got about 10 minutes left to do everything. We only have a couple questions left though, so this will go. I keep clicking the beginning. Let me see. So this is on the final topic. This is synthesis and design. Here is your first one. So these are the big processes. The first one that we're going to be going through is the contact process. So they're asking you specifically what are the conditions that are used and why are these particular conditions used. You may be wondering, is this necessary for the external? I'm actually going to say yes, because industrial chemistry hasn't really been focused on in the 2020 or 2021 external papers. So there is a chance that you guys could get it in the 2022 external paper. So I would probably say that this is going to be like 4 or 5 marks. And I would say 1 mark is going to be you writing the purpose. 1 mark is going to be you doing pressure, just listing the reaction conditions. So pressure, temperature, and then catalyst. So I'd say 2 marks would be allocated to just listing these. And then 2 marks would be allocated to your justification. Okay. For this one, there is going to be a lot of words. So this is one of those non-calculation based questions in chemistry. To put it simply, the contact process is the process of sulfuric acid production. So contact process is a method used to produce sulfuric acid from sulfur and oxygen. Acid from sulfur and oxygen. The first part of the reaction is one way, so that's when sulfur and oxygen form sulfur dioxide. The second part of the reaction is the one where the reaction conditions are important. So in this reaction, the sulfur dioxide from the first part reacts with more oxygen to produce 2 SO3. Now, you don't need to write this down to get the answer for this question. If you want to go ahead and memorize the contact process, be my guest, but 60% of the time, the reactions that you need will be given to you. This question is asking you what the conditions are and why these conditions are used. To explain the conditions, I'm just going to use this equation for you guys, for your purpose, but it's not necessary to include this equation to get the full marks for this question. Because this is an equilibrium reaction, you can use certain conditions to manipulate your yield of useful products. Your useful product in this is going to be this right here, which is the sulfur trioxide. Overall, the second reaction of the contact process, the one that is the equilibrium reaction, this is an exothermic reaction. This, I think you actually do need to know. So delta H is negative here, meaning that a lower temperature will result in higher conversion of reactants to products. However, so technically, according to Le Chatelier's principle, to lower temperature is favored to favor the product reaction. However, if the temperature is too low, then your rate of reaction slows down too much. So, to compensate for that, this reaction is actually done at 400 to 450 degrees Celsius, which is still, I mean, it's pretty high. Don't get me wrong. This is a very, very high temperature, but it's low enough to still drive the forward reaction. And it produces a fairly high proportion of sulfur trioxide in a suitable enough time. So it's not directly, it's not taking 50 years for the sulfur trioxide to be produced. Along with that, we've got pressure to consider. The pressure used in the reaction is very close to atmospheric pressure. Because in the reaction to create sulfur trioxide, a higher pressure will favor the creation of sulfur trioxide. But even at higher pressure is favored according to LCP. However, this is very expensive. Very expensive. And in reality, atmospheric pressures, atmospheric pressures will still produce 99% of the yield. 99% of the yield that extremely high pressures will produce. So therefore, to ensure the safety of the workers in these industries and to reduce cost, atmospheric pressure is chosen instead of a very, very high pressure. Atmospheric pressure. And then a catalyst is used, which is vanadium oxide. You don't really need to justify using a catalyst. Just know that it exists. Okay, so that is your 5-mark question for the contact process. You get 1 mark for the purpose, 2 marks for listing all of these conditions out correctly, and then another 2 marks for the justification of temperature and pressure. There's a more detailed answer with the different steps of that contact process. To get full marks in this question, you don't need to go into that much detail. Is there if you would like to interact with it. All right. This actually came up in the 2020 external exam. So this one is a question that I'm pretty familiar with. I also think that this would be another 5-mark question. So first you need to talk about the type of reaction, and then you want to be talking about the conditions for both of them. I would even talk a little bit about rate of reaction. And also about the resource use. So the two types of reactions that we have is ethanol production by fermentation or by hydration of ethene. Now, to get marks in this question, you don't need to know the equations, but it is useful to know them for different types of questions regarding ethanol production. In this process, we're just going to be comparing the two. So for that, first I'm going to be talking about the process, or like the type of reaction. This is a batch process. So the reaction will occur, the products will be formed, and they'll be harvested, and then left until the fermentation process is complete. The batch is then cleaned out and a new reaction is set up. It's quite inefficient, so it has low efficiency. This is continuous. It is a constant reaction. All of the products that are made exit the system so they can be collected, while a constant revenue of reactants is being pumped in over the catalyst. This is a much more efficient process and is faster. For the reaction conditions, fermentation uses quite low temperatures and atmospheric pressure. For hydration of ethene, it is using very high temperatures or comparatively high temperatures to the fermentation, and requires a lot of energy input. Required. In regards to rate of reaction, this is a very rapid process, hydration of ethene, whereas fermentation is very slow because it takes a lot of time. The reason why hydration of ethene is so rapid is because energy is actively being pumped into it so that it can be utilized in the reaction itself. However, in terms of resource use, renewable resources are used in fermentation. They use the bio waste of plant material and livestock. And for hydration of ethene, they're using finite resources that are crude oil based. That are based on crude oil. There was a question in the 2020 exam that was asking which of these processes is more using the principles of green chemistry, which of these processes is more favorable? And if you were to do it in terms of atom economy, it would be hydration of ethene. But overall, the greener process is fermentation because it's using renewable sources and gentle temperatures and atmospheric pressures, so it doesn't use up a lot of energy. Despite that, though, the process of it happening is very slow. So in terms of industrial efficiency, hydration of ethene is far more important. Okay, there's a summary of that as well. So I think I've got one more question to go through. So calculating the yield that would theoretically produce 25 grams would only reduce in 20 grams. That's very simple. The experimental yield is that divided by the theoretical yield multiplied by 100. That's 4 on 5 multiplied by 100, which is 80%. There we go. And finally, I've got some question time. If anybody wanted any. Right. While that's happening, I'm actually going to export this into a PDF so I can create another QR code for all of you guys. And then hopefully, yes, I can check into Slido, see if anything. Do you think we would be marked down if we dot pointed for these questions? No, not at all. If you dot point these questions, as long as you're hitting all of the correct marks, if you're getting all of the important information in, you won't be penalized for it. How would I have done it? I probably would actually, with the hydration of ethene fermentation question, I would have done them in dot points. For the contact process one, because it was just on one process, I would have done it in sentences. But honestly, it would not have made a difference if you had just hit all of those points correctly. If you haven't been taught these processes, I really hope that you'll be teaching them at least sometime in term 4. That's not very likely though, because I know that a lot of you guys are going into exam block soon. So this might be a thing that you've just got to sort of brush up. Maybe read through your textbook a little bit. Try Atomi if you've got Atomi. Atomi is a fantastic resource. I know my school using it this year, but not for our year. But I've heard that it's really good. So they've got good explanation for that as well. Does hydration of ethene require high pressure in addition to high temperatures? Possibly. I can't quite remember. I know high temperature was definitely one because they needed to speed it over the catalyst so quickly. But maybe. Is it in here? Gentle temperature. Oh, yes. High temperature and pressure needing lots of energy input. Yes, it is correct. You do need high pressure as well. So it is quite, whoops. It is quite a expensive little process. So I've done both of these. Hopefully that QR code is done. I'll just redo what I did before with this one. And then, let's see, September chemistry revision lecture. Hopefully that goes through. It's just uploading now. If you guys have any more questions, not just about chemistry, if you've got any about uni applications or anything, feel free to pop them in as well. I don't mind waiting a little bit extra. And even after I've ended the stream, I'll look at Slido a little bit more if you wanted to put any more on there. That's completely fine as well. Sorry, we're going a little bit over time. That should come through. Okay. Hopefully, if I put this on, that should give you access to the slides with the answers on there, the answers that I've like scribbled on there. So yeah, if you guys have any other questions coming in. Oh, okay. Let me see if I can dual screen this, and so I can have Slido up as well. Perfect. That should work. When considering, I'll do the chemistry questions first. When considering green chemistry, since cost can also be considered, will fermentation be better because hydration is expensive due to its conditions? Actually, that's what the external was asking us to argue. So if you look at the 2020 paper, it's asking you to justify why fermentation is a greener process than hydration of ethene. Like that's a legitimate question that came up on there. So yes, essentially you had to say that fermentation was better because it's like it had less harmful conditions because it's doing normal like lower temperatures and then atmospheric pressure, so you weren't spending as much energy trying to increase the temperature and pressure all the time. You were also reducing costs. So if you look at those two principles of green chemistry, fermentation is more green. But if you're looking at atom economy, hydration of ethene is more green. So it depends on what the question is asking you to argue. I don't think you're ever going to get an instance where you're asked to like argue like which one is more green if it isn't explicit. So with these two, there are pros and cons to both of them, which is why both of them are still practiced today. So you've just got to argue it based on what the question is asking you to do. Is biomed a good course to do as a pathway to medicine? I actually have an interesting opinion regarding this one. It depends on whether or not you actually get into medicine. So some courses make you do an undergraduate degree in some random, like you can do nursing, you can do physiotherapy, you can do pharmacy, biomed, arts if you really wanted to. I'd say if you already have a provisional place in med, biomed is fine because you're learning like med related skills, you're doing a lot of research, you're doing like very basic science, that kind of thing. It's a good break from the rigorous prep that you would have done to get into medicine. If you don't get into med straight after grade 12 and you're still wanting to pursue medicine as a career, I actually recommend you go into nursing or something clinical, because then at the end of the degree, you've still got a job, like you've got qualifications to work in allied health, rather than just getting like qualifying with a science degree, which kind of reduces your employability as well. So if you want to take, like, if you are still wishing to pursue medicine outside of high school, biomed is easier than something like nursing or pharm, but nursing or pharm gives you a job at the end of everything and gives you clinical experience on top of that. So it's a bit of a paradox. I would recommend people who don't get into medicine actually go into a useful degree, rather than spending 3 years in biomed to end up with a bachelor's degree that isn't really going to help them. That's just my opinion. I'm in biomedicine right now, but I do have a provisional place at UQ Med, providing that I keep my GPA up. What is my best advice to studying both chem and bio? Practice exams, textbook questions, and interacting with the marking guide. Knowing theory is only going to get you so far with both of these subjects. If you can't apply the theory to an exam standard question, you're going to get nowhere in your external. So try and source practice exams from places. If you buy any one of our resources, particularly Ed Unlimited, you've got access to practice exams that most people won't have. Other ways that you can source them down, get onto Facebook groups, ask your teachers around. Surely they'll have some revision questions that you can do. But on top of doing revision questions, make sure that you're marking your questions. Seeing how your answer fits in with the marking guide is one of the best ways that you can study for the external, because that marking guide is ultimately how you're going to get your marks. Make sure that you're interacting with like what the question is asking you and you're asking it, like you're answering it properly. How did I decide on doing med? That's a really hard question to answer. I think it was more the fact that I've been learning, like I've been interested and good at doing science related subjects for so long, but I'm also quite a social person. So I wanted to be in a job that was dynamic. I didn't want to just be sitting at the computer all day, typing away data and things like that. So allied health was somewhere that I really wanted to go in. Med was also a career where you could sort of be like in the leadership part of the team, like actually diagnosing people, actually like being the head of looking after like patient care and things like that. So it was a culmination of all of those things on why I decided to go for med as opposed to doing something else in science. But I'm here now and I'm enjoying it. So hopefully I've made the right decision. If you have put in your QTech application but haven't received your ATAR mark yet, can you get a conditional offer from a uni? It depends on what uni you apply to. I think some of them have early offer schemes. Unless you've applied to one of those, I don't think you can get an offer from prior to getting your ATAR. But if you've if you've applied to early offers for Griffith, ACU, ANU, and I think QUT. Does QUT do online? I'm not sure about QUT, but I know Griffith definitely does. Then you could get an early offer, but I don't know if you can get a standard offer without receiving your ATAR. I'm pretty sure they come out around that time. Sorry. Can I put a link up? I don't know if I can do that. Let me check if I can. Possibly. Hold on. These are the ones that I've written. If I can upload this. I'll try and get that worked for you. What would be the harder type of questions to focus on, or the type of questions that are best to do for the chemistry external? That's another hard one to answer. I think if you can do ones that have a focus on the acids and base topics, that would be good. Organic chemistry, like there are 4-part questions. Reaction pathways come up a bit. Finding pHs of, an acid and a base reacting together, that kind of thing. I think just source down practice exams and do as many of them as you can. Look at the chapter reviews of your textbook. They're usually pretty good as well. I think that's really all I can say. I feel like you shouldn't be focusing on a particular thing for the external. Try and just do a full sweep of the syllabus. Make sure that you're interacting with all of those like dot points. They're the things that you're going to get tested on. So give me a second. Let's see if I can. Oh, whoops. Where did that go? Okay. I do not know where that went, but I think it was on my. Yeah, if you guys don't have any other questions, you're free to go. This is basically turning into a Q&A chat now, at this point in time. So that should come through. I'll see if this works. Copy. Try that link, see if that works. Hopefully. What are you studying and where are you studying? I am a UQ student studying biomedicine with provisional entry into medicine. There was a question asking me how did my interview go. Basically, your interview for UQ is dependent on your UCAT score. And so I got an interview offer. And the interview was about a week after graduation. It was when everybody else was at schoolies. I didn't get to go to schoolies because of that interview. But it was 7 stations. Each of them was 7 minutes long. I wouldn't say that it was hard, but it wasn't easy as well. Like it was pretty stock standard. If you're a good person with good morals, you'll do pretty well in the interview. They were just testing your empathy, your ability to problem solve and like critically think and things like that. And there were different aspects being tested in each of the 7 stations. Then after that, basically you get a thank you from the moderator, and then that's it. So it's a pretty short interview for what it is. But in terms of the type of preparation I did, I just read up on some like medical ethics and types of topics that they would be talking about in the interview, and then I kind of just said it. And it worked out well for me. Let's see, live. Here we go. How did I prefer? Any notes and advice? There is, if you've done any UCAT prep, the ethics and values component of situational judgment are basically what's being tested in the medical interview. So if you've got any notes from your situational judgment prep that you've still got access to, have a go and like read through them again, just about like patient confidentiality and like interacting with different groups of people. I had some questions on like childhood autism and youth drinking. That was 2 of the questions that I got. Hopefully that helps. I don't know. But yeah, best of luck if you are sitting a UQ Med interview. And as long as you answer clearly and you're able to engage with the person through the Zoom call, you will be fine. Sort of answered that before. Yeah, QET has the early offer scheme too. Yes, okay. I thought it did. Answered that. Was the interview online? Yes, it was actually. I did 2 interviews for med school. Both of them were online. And I think they're going to continue doing that just because it's easier for interstate people to do interviews on different types of, for different types of unis. And also COVID had to put everything online for us. And yeah, basically you get put into a breakout room with an interviewer, and then at the end of the 7 minutes for your station, you get zipped into another breakout room with another interviewer. They read out to you a scenario and they share screen so you can read the scenario as well. And then, yeah, basically you get the time to give your response verbally and things like that. I think it's, yes, I can request access. Just give me a second. I think that went through. What did I think about JCU Medicine? JCU has a lovely med program. The kind of experience that you'd be getting from JCU Medicine, it's really, really special. Like tropical and rural medicine is something that I am really passionate about. And even though I am down in UQ, I think I am going to be doing my like placements a little bit away from the city just because I feel like the experience is a bit more rich. JCU also has a really integrated med program. So if you are sitting there interview and they ask you, like, why would you pick us over anybody else? I'd say, 1, the smaller class sizes. So you get to know your lecturers and your cohort a little bit better. And that's good for, community spirit and everything. But also you're doing clinical placements from the 1st or 2nd year. It's really integrative and you're starting medicine from day 1. So like, the fact that it's in Townsville shouldn't deter you from picking the med program. It's genuinely a really good program. As far as like the stuff that I've read up on it, I guess. I do know that the written application is going in soon, so best of luck if you are applying to JCU Med, and make sure that your the application is meeting the word count and not over it. But yeah, good luck with any of that. If you guys don't have any more questions, I am going to end the stream because it's nearly 7 o'clock. Thank you all for coming. And if you've got any more questions, please put them into Slido. I'll just be answering them like via the keyboard and not like live, so we're not taking up the stream. All right, I will see you all. Well, best of luck to anybody who's still here, and thank you for coming. Let's go stop.